The 500 crate is hoisted using the ropes AB and AC. Each rope can withstand a maximum tension of 2500 Newton before it breaks. If AB always remains horizontal, determine the smallest angle theta to which the crest can be hoisted. The figure is given in the question. Here, this is a 500 Newton crate which is hoisted at point A. Now there are two cables AB, here is AB horizontal, and AC which is inclined. AC is making angle theta. We have to determine smallest value of theta such that this cable AB and this cable AC, in both the cables, the value of the force, tension force, should not exceed 2500 Newton. If in any of this cable, either AB or AC, value is more than 2500, it will break and the system will not remain in equilibrium. Now here there are three forces, concurrent forces, TAC, TAB and 500 newtons acting at point A. System is in equilibrium. Also we know the angle made by the three forces. Here this is the angle theta, same will be the angle over here, it is a theta. We are also finding the remaining angle. So angle between TAB and TAC, this angle is 180 degree minus theta. Angle between TAB and 500 is 90 degree. And angle between 500 and TAC is 90 degree plus theta. So now we'll apply Lami's theorem. So Lami's theorem is ratio of force to sine of angle between the remaining two forces. So TAC upon sine 90, TAB upon sine 90 plus theta, and 500 upon sine 180 minus theta. We know sine 90 is equal to 1, sine 90 plus theta is equal to cos theta, sine 180 minus theta will remain sine theta. We'll equate equation 1 and equation 3 to get TAC equals to 500 upon sine theta into 1. We'll equate second and third ratio to get TAB equals to 500 upon sine theta into cos theta. Now we'll apply the condition. The condition was in none of the cable AB and AC, the maximum tension has to be kept only up to 2500 Newton. We'll assume that in one of the cable strand, the maximum value reached is up to 2500 newtons. First we are assuming that in cable AB we have reached the maximum value 2500. So we'll put in equation 2, that is 2500, to get value of theta. So once we have put value of theta in equation 2, we got value of theta which comes to be 11.31 degree. Now we'll put this value in equation 1 to get value of TAC. TAC value has came to be 2549.49 Newton. It is more than 2500 Newton, means TAC is going to break. Since when you are applying angle theta is equal to 11.31 degree, here if we will take angle theta equals to 11.31 degree, by our calculation we have found that TAC, tension in TAC is becoming 2549, which is becoming more than this value. So this strand is going to break and this system will fail. In second case, we are assuming that if we will take tension in TAC equals to 2500, we'll use equation 1 to get value of theta, which comes to be 11.54 degree. We'll put in equation 2 to find out what is the tension TAB. Here it has came to be 2448.8 Newton, which is less than 2500 Newton, means TAB is not going to break. Also TAC is taken maximum to 2500. In second case, in TAB value is less than 2500, it is 2448, whereas in TAC it is 2500, means in none of the cable value has exceeded 2500, it is within the range. So when we are using this angle theta equals to 11.54 degree, both the cables TAB and this TAC, these both the tension values are not exceeding 2500 newtons. We can see here it is 2500, here it is 2448. They are not more than 2500, means this cable are not going to break, system will remain in equilibrium. So out of these two angle values 11.31 and 11.54, will take this angle, which is our solution, that is theta is equal to 11.54 degrees.